Welcome back to On the Brink. This is Ria, and in this episode, I had the chance to host Josh Benaron, who is the founder of Bundlr, a protocol focused on improving transaction volume and speed on Arweave, a decentralized storage network, and bridging the gap between Arweave and other crypto networks and applications. In this episode, Josh goes over the rationale behind censorship resistant and permanent data storage, the importance of provenance in facilitating accurate attribution and fair distribution of value, why Arweave's approach to decentralized storage is novel and elegant, and how Bundlr specifically addresses trade-offs in Arweave's design and augments the decentralized storage network. So without further delay, here's my conversation with Josh. Hi, everyone. This is Ria from Castle Island. Today, I'm joined by Josh Benaron, who is the co-founder of Bundlr Network, which is a project that is seeking to improve transaction volume and bridge the gap between Arweave and other blockchains, seeking to scale and optimize Arweave, which is a decentralized and permanent storage network. I think this is the first time that we're actually talking about Arweave or Bundlr in depth on the podcast, so we'll get into what all of that means. But before we kick it off, Josh, can you give us a quick intro on yourself? What were you doing before Bundlr, and what inspired you to build Bundlr?
Yeah, good questions. First of all, thank you for having me. Just to provide some basic history on me, it's maybe not the most exciting story. I haven't been in crypto for 20 years. I'm not one of the OGs, but I kind of got into crypto about three years ago when I was at school, at least very lightly. And then when I went to university, I was studying computer science in the UK. I kind of got very deep into crypto at the kind of the start of COVID, kind of around that period of time. I had nothing to really do, so I was just kind of focusing on learning about crypto. Really, I was always looking for a way out of my degree in computer science. So I ended up discovering Arweave just through research, looking into the storage protocols. I went through the usual kind of journey of kind of IPFS, Filecoin, CR, storage, and then I discovered Arweave. And when I found Arweave, I kind of fell in love both with both with kind of the ecosystem and the developers, and also I became good friends with Sam. And we can get more into this, but I also very much fell in love with the design of the protocol itself, which is fairly elegant. So that was kind of February time of 2021 that I discovered Arweave, and started building Bundlr around April time after some conversations with Sam, who's the founder of Arweave, around kind of scaling problems that Arweave is going to be hitting. And Bundlr was initially really focused on solving those fundamental scaling issues.
How did you kind of develop the skill set and expertise beyond just studying crypto for a couple of years to start building something like Bundlr?
It's very hard to pinpoint kind of what is the one thing which made you really good at what you do, or really enjoy what you do. And what I'll say is that I kind of really got into computer science and programming when I was about 15 or 16. So actually fairly late compared to other people in computer science. And one thing is having that foundation of just spending a lot of time doing that thing, doing a very computer science based things for 4 years. It was that's kind of a good foundation. And then I'd say that the final thing, at least the big thing which got me to the point of understanding of where I am now, is that I have worked with some of what I would argue some of the better people in this, some of the best people in the space is what I'd say. I'm going to show Sam Williams, again, founder of Arweave. I worked with him very closely from about February time, and almost worked with him daily for about 6 to 8 months, which it's quite cool to work with someone who is the founder of a fairly large protocol every day, solving lots of key problems. And there were days when I would work with him for kind of 6 to 8 hours, and we were solving lots of problems. I have all kinds of stories about when we were shipping Bundlr, amongst other things. And Yeah, you can kind of, most of my learning when it comes to crypto came, actually a lot of it came from Sam, or at least
Mm,
working through problems with Sam. So I think between the foundational knowledge of understanding computer science and programming, etc., plus working with someone who, once you get stuck in these problems, you can go to them and be like, how do you solve X, Y, Z?
right.
And then provide you like the foundational answers of why things are. I think if you really have that foundational ability to learn the foundational knowledge, it really kind of set me up for success in that sense.
That's amazing. Yeah, I'm sure it really accelerated your journey relative to some others that kind of go on the journey on their own. You mentioned a number of other file storage protocols and the fact that you found Arweave's design in particular to be relatively elegant. Can you just at a really high level tell us what Arweave is, how it works, and how it relates to some of the other protocols you mentioned?
Sure. So I don't know if I think it's probably easier to go the other way around and actually start with the other storage protocols, because I think it's easier to go from kind of understanding of storage as we know it, and then kind of going up to Arweave, which I say is the biggest step. So storage as we know it is kind of the AWS, just kind of cloud storage that we know. If you store something on Dropbox, that's probably using something like AWS or Amazon in the background to store the data. So that's a very centralized entity. And then kind of came along the IPFSs and Filecoin, which is both built by Protocol Labs, which is essentially decentralized temporary storage. So the idea is that storing something at AWS is temporary. You have to pay monthly fees. Filecoin is similar in the sense that it's temporary. You pay for an amount of storage for a period of time. It's not a permanent form of storage. It's just kind of similar to kind of what AWS is, but decentralized.
Mm-hmm.
And then there's also kind of storage and CL, which is you can kind of look at them as similar to Filecoin in the sense that it's temporary storage. So again, all very similar. And then when it comes into Arweave, it's actually a much different design and a much different set of goals and different problem space, which is what Arweave is a permanent storage protocol. So unlike AWS, which is centralized, or Filecoin storage, etc., which are the temporary storage ones, uh, Arweave is permanent. So you pay once and it's stored forever. That's the idea. There's no recurring fees. And that's kind of the promise of Arweave in 10 words. It's kind of pay once and store forever. That's pretty much it. And I guess to kind of get deep into why, or why and how, but the kind of properties of permanent storage is that you can build this perfectly censorship resistant system. Censorship comes from the fact that things disappear, and that could be in the forms of deletion, updating, deletion, etc., etc. So blockchains inherently are immutable. They stop the updating of data, and they also stop the deletion as well. But they stop the updating and the deletion. But when it comes to storage, you need a new foundational set of incentives to kind of really make things permanent and censorship resistant. And the promise of Arweave is to bring in perfect censorship resistance, the kind of final aspect of what these other blockchains promise. But yeah, the general idea is that Arweave, you pay once, store forever, and it's totally censorship resistant.
Maybe just taking a step back and talking about, I think maybe it'll be helpful for listeners to, from your perspective here, what are some of the issues that have been created by this temporary storage model that proliferate in Web 2?
Any form of, I guess this is more of a question of why this question fundamentally boils down to why decentralization, actually, which is when you're looking at the data layer of a lot of these systems, why does decentralization and permanence make a big difference? Or where has that failed in the past? And you can kind of look at any form of censorship as a form of data censorship. If, for example, going down the very political spectrum, political side of things, it's like, okay, if a specific journalist, their articles all deleted, then that is very much a data problem, because if the data layer itself was censorship resistant, decentralized, and permanent, then no one can do that. No one can really shut down people's voices. Arweave provides the right to have a voice. That's kind of really what Arweave does. And just to provide an example, there was a paper in Hong Kong. it's a fairly well-known paper, and I forgot what it's called. But the point is that there was a paper in Hong Kong, which during the whole Hong Kong issues, which were 2 years ago now, with when China was trying or is still trying to take Hong Kong, and they shut down all of the papers basically, and they ended up archiving all of their papers on Arweave, such that China could not censor that data. And I guess just to kind of expand on that, if you look at all forms of tyranny, authoritarianism, it's always come down to controlling the flow of data, controlling the flow of information. Like if there was a book on how to become an authoritarian, I'm sure there's a book out there. The first step would be control the data, control the news. It really comes down to the data layer. So when it comes to censorship, it's fundamentally, if your data layer is compromised, then your whole system is compromised. That's the way to look at it, and that's the way that Arweave looks at it, in the sense that if you solve the data layer, you've already solved 90% of your censorship problems.
I think one natural question that emerges from that specific use case, and I'm going to hop around a little bit here, but is this question of incentivization. So who is incentivized to actually pay for the storage of this data, which maybe you can think of as like a public good, right? So in that specific use case of I think was it Hong Kong's Apple Daily, was that the publication?
Yes, that was it. I knew
Yeah.
I knew it was a very large one. Sorry.
Yeah, I remember reading about that. In that situation, who took on the burden of actually paying for that data storage? And how do you see that changing in the future?
That's a really good question, yeah, that's a really good question. In that instance, I guess they were incentivized to do so from a kind of value standpoint. They are willing to
Mhm.
front the cost of that for the value standpoint. But I don't think that's the most interesting use case when it comes to Arweave and that question specifically. I think it becomes more interesting when we look at something like creators and paying for their data, which is, I know, a big pivot, but it's kind of another use case of Arweave, which is a lot of the decentralized creator related things, so like a decentralized YouTube,
Mhm.
TikTok, etc., etc. You see this a lot on the Lens protocol side of things, and it's a good question. And the answer is, as creators, at least from a creative perspective, as creators make more money, there will be more incentive to use a more resilient data layer. And the idea is that Web3 is really allowing people to own their data. And what that really means, ownership really means two things, which is that yes, they control it, but two, they can monetize it. They're the people that can fully monetize it. That's really what it comes down to. So fundamentally, you need a censorship and permanent layer in order to have a monetary layer as well, because fundamentally those two things are tightly linked. So kind of tying back to the question, Apple Daily, they were incentivized to pay for it because perhaps it's in their value system, but that's obviously
Right.
not a very scalable system. In the future, I expect creators will pay for it because the money they'll be making will probably be far greater than it is now. At least for the bottom 50% of creators, I think that they are the least looked after by the bigger tech companies like YouTube, and very much as those monetary protocols are built into things like Lens, etc. You will be able to. There'll be more affordability with this storage as well, and it will become very, very important. And you kind of see this, right? LensTube is using us, and a bunch of other video platforms using us. A lot of creator platforms are choosing Arweave because fundamentally having permanent storage gives control to the creator and safety to the creator. And
Mhm.
we can both list tons of people who have been wrecked by creator platforms like YouTube. I can list tens, and I'm not even that deep into the creator world, so it kind of speaks volumes.
I want to keep pulling at that thread of how powerful this primitive and protocol is for the creator economy. And, you talked about it in the context of having permanence and some level of guarantees around content they create, data they create. And I think another really powerful capability maybe that this enables that I've seen you talk about David Phelps, shout out David, has talked about this a lot as well, is, we're moving or are in an era of user generated content and remixing. And today, that's well and good for maybe increasing distribution and awareness of creators, but actual value capture isn't really there yet. Can you talk about how something like the combination of Bundlr and Arweave enables that?
Yeah, sure. I mean, there's lots of things that come into value capture. Most of it comes down to protocolization of each layer, essentially, and it's kind of comes down to what I'm saying. It's like YouTube's system is actually very complex. There are kind of 5 layers to it. Let's say one at the lowest level is the storage, but there are levels above that as well, including the monetary, the how people are paid is a protocol as well. It's a protocol controlled by YouTube.
Yep.
So, I mean, kind of reiterating what I said before, one part of it is protocolizing the payment side of things, which could be automated with smart contracts and things like that. But tying into Arweave and Bundlr and tying into the question, it's really around provenance. And
Mm-hmm.
what provenance really means is knowing basic things about the origin of that. It's about knowing basic things about the origin. That's the dictionary definition. But what that really means in practice is, okay, Ria goes and kind of creates some content. How does she prove that she created that content and not David Phelps? Like how do we prove that? And fundamentally, that comes down to lots of different things. And there's also the idea of when was it created? Did you create it before? Did you just copy it and then claim it? Did David Phelps actually create it and you copied him? Like there are lots of open questions in terms of how do you solve these problems in the decentralized world while making sure that people who are actually doing the work and making the money. Like the whole idea behind Web3, if you look at any system, is okay, the more work you do, the more value you provide for a group of people, the more money you make. It's a very bad definition. But the general idea is it's the same, right? It's like if you look at Bitcoin, it's like the more value you add to the network, the more you're mining, the more value you're adding to the network,
Mm-hmm.
then the better the thing is. And the value in that sense is security. So the more security, and same with proof of stake. It's like, okay, the bigger the stake, the bigger the reward, because you're providing more security for the network. So that's the computer science perspective. But looking at it from just the social perspective, it's like, okay, if I'm creating content that 1 billion people watch, well, I probably deserve to be paid for that. And I don't want you to be paid for something that I created. That's obviously not very smart. So it's a very big question of like, how do we prove the provenance of these things as well? And one of the things Bundlr is looking very closely at, and it ties into Arweave as well, is how do you prove that provenance piece?
Mm-hmm.
And for me, that comes down to 2 things. One is when was something created and who created that thing. And then there's a third step as well, which comes to remixes. But if you're looking at the base content, Bundlr really provides 2 things, and we inherit this from Arweave as well. So Bundlr actually provides accurate timestamping on data. So the idea is that if you upload some data to Bundlr, you'll get an instant timestamp back of exactly when it happened to the millisecond. So you have this very accurate way of measuring when something happened. So just to provide context on, perhaps if you use the Solana, for example, the time resolution for Solana is 500 milliseconds, the block time. For Arweave, it's 2 minutes. So every 2 minutes you get a timestamp. So it's not as
Mm-hmm.
accurate. But Bundlr provides a real-time timestamp. So it can essentially build these real-time provenance chains where we say, okay, Ria created content, I clipped it, David created a remix of my clip, etc., etc. And then you can kind of build this provenance chain of kind of who did what at what time. And you can kind of see, hopefully I'm drawing a picture which you can
Yeah.
conceptualize here, which is that you can essentially drive where the money's going based on this provenance chain. And the other thing is that, at least from a kind of feature standpoint, Bundlr one provides the timestamping, but you're also allowed to label data in multiple ways as well. So if you want to prove that it's you can easily add kind of labels which essentially allow the data to be queryable and searchable. So it's a very kind of, at least from a developer perspective, it's very cool. And the final thing, which I have to say Bundlr doesn't solve, but I have had a lot of talks about recently, which is that with this kind of topic being very important and provenance becoming very kind of big topic, apparently for the last kind of month or so, I think zero knowledge is going to be a big part of this as well, which is
Mm-hmm.
that, okay, if I have clipped a video, if I've cropped a video, how do I prove that I've cropped a video? So that's actually a very difficult computer science problem, which is like, how do you actually prove that this clip came from this other video? It's actually really difficult to solve. And the idea is that, within I would argue in the next 5 to 10 years, we'll have pretty scalable solutions which allow you to do that. So you'll be able to mathematically prove that David clipped something that I created that you originally created at the beginning. And then, at the point we have mathematical proofs of these things, then you've built a very decentralized system which allows you to flow the money in a really even way. Like imagine on TikTok, if I created a video and then everyone on YouTube and everyone started clipping it and putting it on TikTok. So if I created a video on YouTube and then you start clipping it, putting it on TikTok, well, I'd argue you deserve some of that revenue share because you're distributing my content. And you can only really do that when you have things like the mathematical, like the accurate timestamping and the provenance that Bundlr provides, plus the permanence.
And the proof, yeah.
And then you add the proofs to it, and then you have this, give or take a few gaps in the solution. You basically have a full solution of proving who did what, and then you can build this amazing monetization protocol on top of this, fully decentralized, such that everyone who distributes your content and is the best at distributing content, you get a share of the revenue as well. And I think we're probably for that final really good solution, I'd say we're probably 10 years away. But the optimist in me would like to say we're 5 years away. But that kind of ties into how Bundlr is solving things, and then also how it will tie into a future solution as well in 5 to 10 years time.
Yeah, I appreciate you kind of identifying some of the gaps to actually getting to that point. I want to take a step back and talk about what exactly Bundlr does for Arweave and maybe some of the problems that it solves for Arweave. And you mentioned one of them as you were talking, which is this difference in block time and the ability for Bundlr to kind of provide real-time provenance and guarantees. But talk a little bit more about, as you were working with Sam before Bundlr was live, before you came up with the idea for Bundlr, what were some of the maybe trade-offs that Arweave was making that you felt like you could solve with Bundlr and that you are solving today with Bundlr?
Firstly, Arweave is a great protocol which really focuses on doing a few things really, really well, which is a good way of designing computer science systems as a whole. And what Arweave is very good at is storing large amounts of data permanently. That's pretty much kind of in a really basic way how to describe things. And I'll come to some of the trade-offs there. But the idea is that the limit for Arweave when it comes to storing data is it can store 2 to the power of 256 bytes per 2 minutes, which is, by the way, that's basically per block. It can store more data than exists on this entire planet. So there's no real fundamental limit to the amount of data that can be stored. And this comparing this to something like Ethereum, it's like it's Ethereum a megabyte costs thousands of dollars. On Arweave, it costs a cent or less than a cent, actually, a thousandth of a cent. And yeah, it's kind of a huge difference. But kind of tying into the trade-offs there, well, Arweave has the same kind of trade-offs that something like Bitcoin has, which is, okay, what if a billion people want to use Arweave at the same time? Or let's use Bitcoin. If a billion people want to use Bitcoin at the same time, well, you're going to run out of block space. And same with Ethereum, right? You run out of block space. And the same thing kind of happens when the demand well exceeds the supply, and the supply being block space in number of transactions, then the cost of doing those said transactions is much higher. So just before Bundlr launched, I mean like 2 weeks before Bundlr launched, Arweave's block space was totally full. So there were times when there were like 100,000 transactions within a minute. Because there are lots of people dropping NFTs and stuff like that, obviously. Mm-hmm. And fees would go up 100x. So when you're paying, $1 a gigabyte, you are suddenly paying $100. And that's just kind of the basics of a blockchain fee market. But that kind of explains some of the trade-offs that happen when you have this system that can store lots of data, but only a certain number of transactions within a minute. And kind of tying it into Bundlr, the thing I used to say is, okay, Arweave can only do 30,000 transactions an hour. It's not that many. How do we scale this to 30,000 transactions a second? That was always the kind of the initial vision, anyways. And recently we scaled up to 50,000. I don't know if you saw it a week ago, but yeah, so we kind of hit that goal as well. But that was kind of the original trade off with Arweave, and also what what Arweave what Bundlr tries to solve. I guess the final thing is that uh, to use Arweave you need R. Like that's kind of perhaps an obvious one, but acquiring R can be sometimes a little bit difficult. And also, if you're building a system on multiple chains, then do you want to have two tokens, like Amatic tokens and R tokens? Do you want users to have both those tokens? There's lots of design space issues there. And yeah, Bundlr looks to solve a lot of these problems.
Can you talk a little bit about how exactly you do that? How have you structured Bundlr to scale Arweave? And also, I think one of the biggest value propositions is to kind of serve as a bridge between other chains and Arweave by kind of not requiring them to have to pay in Arweave's native token. So yeah, talk a little bit about how you actually enable that.
Yeah, sure. So to kind of summarize Bundlr in three ways, we very much focus on speed, scalability, and multi-chain. Now I'll kind of tie into it. So speed being how quickly can you upload? So with Arweave, you have to wait 10, 20 minutes for something to be confirmed, essentially, or confirmed to a high enough degree. On Bundlr, it's pretty much instant. It's less than 100 milliseconds. And then scalability is like, okay, how many people can I have on the system at one point in time, which comes down to the transactions per second. And then the final one is, okay, how do you let people use other tokens to buy or use permanent storage essentially, and use Bundlr and slash Arweave? Those are kind of the three problems we solve. So looking at the design, whenever I explain to people who don't necessarily know as much about Arweave, I always like to compare us to optimistic rollups, which is a scaling solution on Ethereum. But the idea is that you take a bunch of layer 2 transactions, you stick them all together, and you dump that as a single layer 1 transaction on Arweave. And the idea is that, okay, if you can batch 1,000,000 transactions in a single layer 1 transaction on Arweave, and there are 1,000 transactions in the block, simple maths, 1,000 times by 1,000,000, which is a million per transaction, you've got 1,000,000,000 transactions per block. So every 2 minutes, you can have 1,000,000,000 transactions. And that's the very basic way of how Bundlr scales. It's actually the way that you scale all blockchains. It's always some form of rollup. It's a way of batching a bunch of transactions together. It's how the Lightning Network works. It's how Ethereum rollups work. It all uses that to some degree. The reason why I say it's like an optimistic rollup is more about the fact that we dump all of the data on the base chain. So we dump the entire state on chain, and the reason that's important is because that means it's fully decentralized. There's no state stored off chain. Anyone can verify that Bundlr is being honest. That's kind of the key part there in kind of maintaining some degree of decentralization at this stage. So that's kind of the scalability part, and then from a speed perspective, we very much kind of optimize speed, and we have to kind of make the heuristic decision that kind of something like I don't use Polygon. Polygon's a sidechain. Let's say something like optimism, or okay, zk. This is I'm getting into a debate here, but no, I meant more in terms of scaling things like speed. We use kind of centralization vectors, sequencer kind of models, such that you can essentially handle any number of transactions. But the cool thing is that with Bundlr, it's more for non-financial use cases. And the key thing there is that you don't need to have any shared state. So fundamentally, when you're using something like Arbitrum, Optimism, etc., you're still limited by the fact that everything kind of needs to know about everything else. And it's like, imagine if you're in a crowd of 100 people, and before taking a single step, you have to ask 100 other people, is this okay? Like, that's kind of maybe a crude example, but that's kind of how blockchains work. And that's how also L2s work. But the thing with Bundlr is that there is no shared state. So you inherently can kind of scale Bundlr infinitely. And what we kind of say is that we can theoretically scale Bundlr to millions of transactions per second if we needed to. And that's super cool. And there's no kind of increase in fees as well. So it's a very different design to the Ethereum L2s. And then I guess the final thing, which is the multi-chain side of things, which is actually a cool innovation that we did, which was essentially the transactions on Bundlr are these kind of cool binary formats which allow you to sign it with different keys. So when we actually integrate tokens, we're actually integrating the actual cryptography of each chain. So when we integrated Solana, we actually integrated this cryptography curve known as ED25519, like the specific curve that Solana uses. And then that inherently means that we can use kind of Solana keys to sign. So you don't even need an Arweave key at all. You just need your Solana key. You need some Solana, sign the transaction, pay for it, and you're done. You don't even really need to know you're using Arweave. That's kind of the key thing here. You're abstracting all of this away, and it just feels like you're using Solana. So that's kind of the high level of how this all works.
Going back to your second point around batching transactions and then settling them to the Arweave, let's call it L1 if we're continuing using this analogy of Bundlr as an L2. Talk a little bit about like the guarantees that users of Bundlr are getting when they're using Bundlr, and how you kind of enforce those guarantees.
Sure. So there are guarantees that we inherit from Arweave. So the basic guarantees around retrievability. So there's this concept of, I won't go too deep into this, but there's a concept of availability and retrievability. Arweave provides guarantees on retrievability, which is that, like, okay, in 100 years' time, you're going to be able to retrieve this data. That's kind of the guarantee. So there's that kind of guarantee that Arweave provides. And then for Bundlr, it's really about providing guarantees around the time that it takes to get on chain. So Bundlr, it takes about up to an hour for data to settle onto, I use the term settle, just use friendlier terms, but to get onto Arweave. And it's really about providing guarantees such that you know that within an hour, your data will be on chain. That's kind of the idea. And the way that really works is we have this kind of receipt system, which is that you post the transaction to the network and you get this receipt, which is essentially proof that you've uploaded this transaction. And it has this block cutoff point, which is basically a deadline saying that, okay, if this transaction is not on Arweave, not on L1 by this block, then the node on the network can get slashed. So imagine that it's 100 blocks. Each block is 2 minutes. So it's 200 minutes. If the block cutoff point is in 200 minutes time and they don't get the data onto Arweave within that 200 minutes, then their stake is slashed. And that's kind of the design that we go for within Bundlr.
And then do you also provide some kind of redundancy guarantees?
For Arweave, I guess, to go deeper into what permanent means, permanence inherently means redundancy. So to make something permanent, you essentially need to provide the incentives to store things for long periods of time in several different locations redundantly. That's kind of the definition. That's a very non-fluid definition of permanent. So Arweave really provides guarantees on retrievability by providing this kind of concept of permanence. And kind of double clicking on that a little bit. The idea is that Arweave provides very strong incentives around miners storing data, such that the replication rate of the network is currently it's 45 plus. So there are 45 copies of your data stored on the network. It's being reduced to 15 because 45 is, I can tell you now, 45 is too much. A lot of research says that beyond 10, it's kind of pointless. So it's kind of being reduced to 15. But the idea is that if you provide strong enough incentives such that a group of random people want to store your data, and there's at least 15 random people who want to store your data for the next 100 years, then you'll be okay. This is kind of the definition. This is the very kind of trimmed down definition of what permanent means, and also kind of ties into those guarantees that you get as well.
And today on Bundlr, who is actually conducting the bundling or the batching of transactions?
The whole network is currently operated by us. We are very transparent about this. We try to be. So yeah, the current state of things is that we're fairly centralized in practice. In terms of kind of where we are, we're planning on decentralizing, and if not to shoot myself in the foot, but we plan to do this sometime next year. And we hope to have a testnet by the end of this year as well. So it's kind of a key focus. It is it's probably our second highest priority right now, beyond just kind of building things which are useful. So we are very focused on decentralization. And tying back to what I said, it's like, fine, if we believe this data layer needs to be decentralized, well, we're just kind of incriminating ourselves by saying that, okay, we're totally centralized. So what's really the point there?
So, I mean, yeah, maybe talk a little bit about the path. I don't know how much, how far along you are in designing the decentralized version of Bundlr, but what does that look like? What would the requirements be? I don't know, maybe that's a question that you're still answering, but yeah, what would the requirements be to be an entity that batches transactions on the network?
It's a good question. When token? No, but no. But all seriousness, I don't want to share any unbaked, half-baked thoughts. Is kind of what I try to avoid. But we do have lots of different designs, and really, when you're looking at designing a decentralized system, it's like, okay, one is like, what services do you want your network to provide? Because you look at like basically all networks and all blockchains are services. They're service provisioning things.
Mhm.
So Ethereum provides, I mean, I would argue Ethereum provides a service of consensus. That's really all it does. All it does. And we value that, at $100 billion plus. Like we think this social consensus is extremely powerful. And the idea behind Arweave is, okay, the service is permanent storage. And you could also argue the service is kind of this right to speak. And when it comes to Bundlr, it's okay, the service we're providing is kind of a few things. One is the kind of the scaling of storage, it's the arbitrary kind of scaling of storage. Two is that kind of guarantees on time, the very high resolution timestamping system that's built into Bundlr. And then the third one is we have some data availability guarantee. We have some data availability guarantees as well. So those are kind of the three services that we kind of look at from a network standpoint. And then after that, it's really about design. It's really about deciding on where on the spectrum of decentralization do you want to sit. What
Mhm.
consensus protocol do you want? And just to kind of show you the two sides of the spectrum, there is Binance. There's Binance Chain, which is basically run by Binance, and it is run, not basically, it is run by
It
Binance,
is run by
and
Binance.
yeah, and the most decentralized being something I would argue like Ethereum,
Mhm.
ETH Maxi over here. And then there's kind of things in between. There's Arbitrum Nova, which is kind of on the Binance side, and then there's kind of the I don't know what else is kind of placed on the side, but it's kind of, you get the idea. There's a spectrum, and really, where we need, when you're designing a decentralized system, you need to decide where you sit on that spectrum, and that decision isn't made yet. In general, it's going to be some form of Oracle system. It's like there's going to have to be some form of off-chain verification of things, which is really just an Oracle system. But beyond that, yeah, no details to share quite yet. You'll be the first to know.
Great. I'm excited. So I want to talk a little bit about adoption of both Bundlr and Arweave. Talk about, when did Bundlr go live? What portion of activity on Arweave is flowing through or directed through Bundlr today?
We launched around. I actually don't know the exact date. I should know this, but we launched around July August time in 2021. Kind of the
Mhm.
I remember the heart of COVID. Yeah, so we launched around that time, and we actually launched with Metaplex, which is Solana's NFT infrastructure, which is kind of where the boom began. And at the time, we were doing a large volume. I mean, we were doing in the 90s of, we were definitely doing 90 something percent of the transaction volume, and I think to this day we are still doing it. I mean, right now we're doing 2 million, well, 1.7 to 2 million transactions a day at the moment, and I think that accounts for a majority of the transactions. I think above 90%. So seem to have still a fairly large percentage right now.
Are there any use cases where a transaction would have to flow directly through Arweave and not through Bundlr, or is it always better to just flow through Bundlr?
There are trade-offs, is what I'll say. So when you're working with Arweave, you have to eat the fact. You have to deal with the fact that you will have to wait for things to be confirmed if you want to build a highly resilient system. You need to use R tokens. It's not that big a deal. Um, and you also need to go through this process known as seeding, which is this idea of getting the data onto the network. So there's transaction confirmation, and then on Arweave there's this concept of transaction seeding, which is like, okay, how do I get a few miners to store my data? Like, how do I get them to store my data straight away? Bundler provides guarantees on seeding. It's not something we talk about too widely because it's this very kind of technical topic, but it's generally we provide guarantees that data gets stored in the network very quickly and very efficiently. So you kind of have to deal with some of the lack of guarantees there when using the base chain, because you have to go through services which don't provide those guarantees. But I guess kind of playing devil's advocate on Bundlr, Bundlr is very much optimized for smaller transactions, only because the way one of the cool properties of Bundlr is that if you're paying for a transaction which is below 200 KB or kilobytes, it's cheaper on Bundlr than on Arweave. It's much cheaper actually. So there is actually this pretty like the most interesting use cases are ones like desocial, etc., where it's like lots of small transactions for Bundlr. And there's an argument if you're going to go ahead and store a petabyte tomorrow, which is 1,000 terabytes tomorrow, you might want to use the base chain. It would be cheaper, but you would also lose a bunch of guarantees that Bundlr provides. You'd lose instant retrievability. You'd lose the guarantees on seeding. You would lose guarantees on confirmation. You have to wait 10, 20 minutes to be sure. Like you can't build real-time systems, and most systems are real-time. Like in some ways, all systems require instant feedback. So there are trade-offs. It's not me saying that you wouldn't, but there are pros and cons.
And would you say that Bundlr has been like specifically architected for Arweave, the decentralized permanent storage network, and at this point and maybe forever is like inextricably linked to Arweave? Or would you foresee a need for something like Bundlr on other decentralized storage networks?
Yeah, I mean, I don't want to talk negatively about other storage networks, but my general
I
view
mean, you're
is that
opinionated. Yeah.
I have opinions, but I'm not sure if I should share them. It's a very big difference. But yeah, so right now the architecture, there are specific nuances. Like this concept of seeding is obviously a very Arweave specific thing. There are parts of the system which are very kind of nuanced, but the idea of something like bundling at a much higher level is something you need for something like Filecoin. So just to provide basics on Filecoin, the way it works is you kind of have to buy 32 gigabyte sectors. I forgot what they're called, but basically you need to buy 32 gigabyte kind of chunks. And if you want to efficiently pay for storage on Filecoin, you need to pack data together. So if you've got 100 gigabytes of storage, you need to essentially pack or split that into 3 efficiently packed, or I guess 4 efficiently packed sections. And that's just how Filecoin works. And you can kind of see how Bundlr fits into that. It's kind of this way of automating that batching of transactions such that it would automatically fit it into these 32 gigabyte chunks. That's a theoretical design. What I will say is that frankly we're not focused on other storage protocols. At least right now it's absolutely not a priority whatsoever. There are lots of we truly believe that permanent storage is the way the world is going to go. It's where the creator economy is going. It's where social is going. And I think it's going to be used. Within the next 10 years, I think Arweave is, from a storage volume perspective, no token speculation, it's going to be 1,000x or more from a storage perspective, like no doubts. 1,000, I'd probably say more. I'd say in the tens of thousands.
Yeah.
And I have absolutely no doubts of that. So we're very much focused on Arweave and driving a lot of the values we kind of have with Arweave, because fundamentally we're also a very value driven company. We're a protocol, but also the company that develops this protocol, we are very value driven, and fundamentally we truly believe that Arweave is the most decentralized and censorship resistant data layer out there, and it's where most data should be, at least most censor prone and data should go for things like NFTs, etc.
Given, in your view, and I think a lot of people share this view as well, given that Arweave is so elegantly designed and offers guarantees that have never been available before, why is activity on Arweave relatively lower compared to a system such as Filecoin? that seems to have, the greatest market share of decentralized storage protocols today?
I've actually gone very deep into this topic recently in the last kind of probably 2 months. And okay, one question is and not this is more of a rhetorical question, but like how do you look at what is the most popular thing?
Right.
Perhaps one question, and there
Yeah.
are two ways to look
Are
at
we
it.
looking at the right metrics? Yeah.
Yeah, I mean, one thing, like my opinion is you look at demand side revenue. That's kind of my view of the world, and even by that metric, it's not as big as something like Filecoin. But what I will say is that Arweave is a new use case, and sorry, this is like I know people at Protocol Labs, they're great people. I'm not saying anything negative about Protocol Labs, but what Filecoin really is what we already know. It's temporary storage at a fraction of the price. So they're really just selling something that already exists at a fraction of the price. And you can kind of see how, okay, it's much easier to onboard a bunch of storage doing that. When you build a fundamental new technology, the curve is much slower, at least at the
Mhm.
start. It's going to be much, much slower. And I, Filecoin, it might be like that because it's a cheaper version of what already exists. Arweave is a totally new use case which also is solving new problems. And it's not just looking at the old problems and applying Arweave to it. It's also okay, like what are the new technologies which Arweave enables? Whereas
Right.
Filecoin, from a storage perspective, temporary storage perspective, they can just kind of sell to the old market. So from a
Totally.
business perspective, you can kind of see the difference. And yeah, so it's a valid question, and I do think demand side revenue is important. I think it matters that people on the network are highly incentivized. What I will say is that devil's advocate to people saying that the revenue on Arweave isn't very good is that okay, it might not be that good right now, but are miners on the network incentivized? Yes. So there's no real need to complain in that sense. At least from a kind of what Arweave is trying to solve, it's solving what it's trying to solve because it's incentivizing people on the network to do what the network is meant to do. So great. Um, yeah, there are absolutely valid arguments on both sides. I'm personally not worried, only because I think the revenue will increase over time.
Yeah. What about I think that makes sense. It's easier to grasp something that is doing a decentralized version of what already exists today. Much harder to grasp. Maybe also, and maybe you can speak to this from a cost perspective, the upfront cost of using something like, and maybe the business model is similar to using some of these temporary decentralized storage networks relative to something like Arweave, where the upfront cost is higher, if I'm interpreting it correctly.
When you use something like Filecoin, you work with a more centralized provider, which provides this kind of subscription model usually for storing data, and that's a very typical model. People are very used to this. People have used S3, these usage-based models, for a long time. And then Arweave, it's very different. One, it's a totally different service. Again, that service idea. It's permanent storage, which means the use cases don't overlap as much as people think.
Yeah, it's not
And
one to one.
yeah, it's not even close to one to one. Yeah, and from a cost perspective, yeah, it's kind of strange to people, and I actually understand. It's like, okay, one is like, why am I paying for 200 years, like 100 plus years of storage, for permanent storage? Uh, and also, why am I paying upfront now? Why do I have to, like, on S3? I don't have to pay for the next 100 years on S3. Why would I do that? And it's really about, again, it's about trade-offs. It's S3 doesn't provide you the guarantees that Arweave provides you. That doesn't provide you the guarantees that Filecoin provides you. They all have trade-offs, and fundamentally, I think it's not about like, oh, Filecoin versus Arweave versus S3. Although I think S3 versus Arweave is an interesting conversation, but nonetheless, it's not Arweave versus Filecoin, etc. It's that they all service different use cases. Like there is a use case for temporary storage, there is use case for permanent storage, and they don't always overlap. Arweave just provides very different values that are very different services than other people.
And maybe going back to one thing that you were talking about at the beginning of the conversation is this, and maybe we haven't solved, the incentivization of doing this, the incentivization piece of doing this, but are we actually serving as a permanent archive for like all data created on the internet, right? That's something that's uniquely enabled by something like Arweave.
Yeah, and I guess the way to kind of think about this is this: our depiction of history has always been dependent on the stuff that we can find. It's always been a probabilistic kind of a low probabilistic guess on what is happening. And I'm not here to fight historians, but my point is that going forward in 200 years' time, for the first time ever, we're going to have 100% clarity on what was happening 200 years prior or now, because we have protocols like Arweave storing this data permanently, providing these guarantees. So for the first time ever, we're going to have guarantees on history, or at least we'll have as much information as possible to provide those guarantees, or get as close to those guarantees as possible to avoid semantics and pedanticness as well. So kind of tying into the internet thing, yeah. So like you could archive the entire internet tomorrow on Arweave, and people in 200 years time will be able to view it and be able
Yep.
to draw a picture of history. And just to kind of show a project which uses Bundlr but isn't Bundlr, there's something called the Alex Archive on Arweave, which is essentially this idea of how do you incentivize people to archive things. And the idea is that you archive some information and then you essentially own a percentage of the assets that are created by that, and everything is turned into some form of collectible in some form. And then imagine if you were, I know this maybe a bad example, if you're archiving this is a bad example, the Torah or something, because I've spoken to someone about this, and like, okay, a million people put in $1 million, and then someone kind of got a specific page of the Torah. It's like, okay, like I own a percentage page of the Torah. I don't know if I should use a religious book as an example, but there's still, you can kind of understand how you can build these core incentive mechanisms to really incentivize the archiving of this kind of data as well. So it's a super interesting use case.
Yeah, you just answered the question that I had in the beginning. So we came full circle. Well, before we end the conversation, I do want to talk maybe a little bit more directedly about some of the use cases of Bundlr and what people have really been using Bundlr for. You know, you mentioned NFTs, you mentioned L1s like Solana. Talk about maybe the if you have line of sight into this, the breakdown of activity across different different categories of projects that are using Bundlr today. You also talk about social, so yeah, talk about all of that.
Yeah, I mean, again, it's like, how do you break it down? We break it down in two ways. One is storage volume, and one is transaction volume. It's like not every transaction is the same. Some are big, some are small. I remember I saw someone on Twitter saying that. But yeah, the idea is that it depends on how you measure it. So from a transaction volume standpoint, it's much easier for us to measure. And right now, it's actually a real mixture of use cases. We have a large percentage, maybe somewhere between like 20 to 30% is archiving. We have a large Oracle users storing a lot of the Oracle data, which is probably another 20, 30%. NFTs is still a large percent. It's probably about 20%. And then the rest is kind of hard to identify. So, like categorizing decentralized transactions is a really difficult data science problem. So that's kind of the use case. But tying more into more interesting use cases, and where I see Bundlr going as well, is I think for that really high throughput, low latency protocols and dApps like the social messaging protocols like the push protocols of the world, etc. When these dApps eventually decentralize, permanence is going to have to be required to build these systems. And I think Lens is really leading with that kind of message. And permanence is required for censorship resistance and ownership. And if you need low latency in a decentralized way and permanent, then this is kind of where Bundlr comes in. So I expect in the next 2 years, if I was to guess where Bundlr is going, I think a lot of volume will come from messaging-like protocols like social, push, XMTP, etc.
Playing devil's advocate from the user's perspective, you know, what if I don't want permanent storage of all of my interactions on social networks?
Two arguments. One is fine, use temporary. The other one is people look at permanent storage as this really scary thing. And what people don't realize is that if you went and posted a video on YouTube, that data is permanent, believe it or not. And the reason I say that is because if you're famous enough, someone's downloaded that. even not even if you're famous enough, someone has downloaded it. There are crawlers, there are people downloading these things instantly.
Mm-hmm.
Like the stuff exists somewhere, so it's still permanent. The thing that YouTube does when it removes videos is it stops distribution. Like it stops the thing being shared. That's really what they're doing. It's not stopping it existing, it's the sharing part. So what I say to people is that permanent storage isn't about, oh, like everyone's going to be able to see what you've ever done. No, no, no. It's really about stopping the distribution. The searchability on something like Arweave by default, it's like it's finding a needle in the haystack. Just like if you got into YouTube's database, finding the one video that you've created in the S3 bucket is a needle in the haystack. So it's like, it's really about the new systems are going to be built around this idea. I truly believe that people will learn to use permanent storage and then build systems around that, around stopping distribution if they want to delete things. And a really kind of cool idea here, and this is a shield to Lit protocol, but with Lit protocol, which is this kind of encryption protocol and a way to have essentially link smart contracts and on-chain stuff with encryption to control access of specific assets.
Yep.
You can actually if you upload a video to Arweave that's encrypted, or to Bundlr that is encrypted using Lit, you can essentially instantly revoke people access to it, and you can essentially stop people from being able to view it as well. So that's also a really cool way of doing it as well. So you have the censorship resistance and the ability to revoke people's access to that data under certain kind of decentralized conditions as well. So like the three-part answer is yes, there are times when you want to use temporary storage, but the way that I see things is permanent storage is the way it's going to work. And there are 100 different ways to look at this and 100 different ways to really solve this problem as well. It's not a reason to give up on the benefits of, or the reasons why we're doing this.
Totally. That I'm glad you brought up Lit, because one of my follow-up questions was going to be, what projects and protocols do you kind of see as complementary to something like Bundlr? And it seems like that definitely fits that question. So yeah, I think with a lot of these primitives that are emerging today, I think the composability that's enabled by crypto networks, you have the ability to create really powerful primitives and determine parameters around them that work for you.
Yeah, no, that's really true. And what the two things I'll generally say to that is like, yes, there are lots of problems to solve with this, but generally, like it's not, we create a system, there are new problems, so throw away that solution. It's like, okay, there are new problems, therefore there's going to be more solutions to that problem. And just to kind of answer the secondary question as well, or the primary question, which is what other protocols do I see as being complementary? I think LivePeer is an interesting one, which is that I see a lot of trend around video, and there also needs to be, again, going back to decentralizing and protocolizing the whole stack. I think LivePeer is going to be a big kind of component to a lot of these solutions going forward. When there's a decentralized YouTube, decentralized TikTok, and there's LensTalk, LensTube, that all use LivePeer and Bundlr together as well. So I think that's also going to be a very cool protocol to look at in the next few years.
Well, Josh, it's been an absolute pleasure having you on. I really, really enjoyed this conversation, and we went a little bit all over the place in our journey through understanding Arweave and Bundlr, but I think we did a pretty comprehensive job. So really appreciate all of your time.
Likewise, it was really good. Thank you.